So we were talking about a prediction model, which was linear regression. And what exactly was it? We spoke about an example where we had the prop year and the property rates, something like this. And what we did is we drew a line like this, which was called as the regression line. And then based on this particular data, we will make a prediction. So we will continue with another set of prediction models today. So the first one that we have is logistic regression. Now, a lot of times, what we are required to do is we are required to get an answer which is categorical. So now, in the first part of the discussion today, the most important word, or the one which you'll be hearing so many times today, is categorical data. Now, what do you mean by categorical? Now, over here, what I'm looking for is I'll be getting only answers like this, right? See, suppose if you put a question, the answer would be yes or no, true or false. Will it rain today? Yes or no. I can't give you the value, but yes or no is what you'll get as the answer. So whenever you have the answer as true or false, or yes or no, that is what is called as categorical data. So we will be working with categorical data today. Now, logistic regression works slightly differently. So let us first try and understand the concept. We'll try and understand the mathematics behind the concept. And then obviously I'll try and demonstrate this with the help of a program. Also, we will be discussing at length a very important thing that we have in machine learning, which is data wrangling. So we will talk about that as well. Right. So let's get started over here. Now, see, when you say a regression model, basically regression model is something which is going to make predictions. Now over here, what I'm planning to do is I'm planning to convert the data that I need to process in the form of zeros and ones, or true or false, right? And then we will be making predictions based on that particular data. Okay. Now, a linear regression, like the name suggests, works on a straight line. Your best fit line is a straight line. But when you talk of logistic regression, it works on the concept of a sigmoid. The curve that will represent the behavior is always a sigmoid. Now, what we'll do is, for all the values that you get, we will be getting the values in the range of 0 to 1, which would be like this on a sigmoid. So it might get plotted here, 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 it might get plotted here. But for me to be able to give you the result, we will just see where exactly it falls on the sigmoid. So guys, observe this. What we'll do is, once you get the sigmoid, right, the relationship, or for getting the sigmoid, this is the relationship which we are required to use. But again, what happens is I have a module called logistic regression available to me in Python, which will do all this stuff for me. I've been stressing on this in the previous session, and I'll keep doing it till the end. See guys, for literally everything to be done, you have predefined methods, you have predefined classes. All you need to know is what these predefined classes are, and accordingly what these predefined classes are, and we just need to put the data in the right manner, or we just need to input the data in the right manner, in the right manner possible. So that is what we need to do. Now, once we've got this segment, now this curve, the data can get plotted wherever you want, something like this. This is what we need. But now, over here, how do we decide what should be the answer? So we always work with a value called threshold. Now, what is threshold? Threshold is basically a predefined value that we will have. And what we'll do is, suppose I've gone with a threshold of 0.5. Now, please, there's absolutely no compulsion that your threshold has to be 0.5, right? Your threshold has to be 0.5 only. No, what you can do is you can have whatever the threshold that you are comfortable with. And once you plot this, what I'll do is, if any point which is plotted above the threshold, my answer would be, say, yes or true or 1. And anything which is below the threshold, our answer would be no, or answer would be false. So please understand this. Unlike linear regression, logistic regression model is not going to give you the value as an answer. It is going to give you a categorical answer, which is true or false, right? Or which is yes or no, right? So please understand this. So this is a regression model, this is a prediction model, and and that is how it is going to work. We will have a sigmoid, and using that particular sigmoid, we will have a threshold, and depending on where exactly the results get plotted with reference to this threshold, the answer would be true or the answer would be false. The way we had a single expression for a straight line as y is equal to mx plus c, similarly you have an expression like this which will calculate the sigmoid, and for all the values between minus infinity to infinity, we'll get the values between 0 and 1. So that is how it is going to work. But again, all this will happen in the background. But more importantly, what you need to understand is data wrangling, right? So data wrangling is something which is important for us, right? So let's first understand what are the steps that we will be using, or what are the steps that we'll be using while implementing logistic regression, and then we'll talk about how exactly are each of these steps implemented. Any doubts with this so far? Okay. Now, when we go ahead and implement logistic regression, the different steps that we are required to carry out are: first is we'll need to collect the data, whatever is the data that we need to whatever is the data that we need to pursue. So that is what we will have over here, collecting the data. Then you have analyzing the data. We'll need to analyze what the data is all about. What do we have in that data? How does that data work? That is what we'll talk about. Data wrangling. Data wrangling will basically talk about how to clean the data, how to get the required data properly. Now, this is something which is extremely important. See, as a data science professional, or as a data analyst professional, you should be really good at the process of data wrangling. We'll see this in a lot of detail today. Then you have training and testing of data, and finally you have to predict the accuracy of the model. So that is what needs to be done. So there are 5 steps: collecting the data, analyzing the data, data wrangling, train and test, and check accuracy. So that is what we are required to do. So these are the 5 steps. Now, how exactly are we going to be implementing this? Now, we will be working on our data, which is a classic data set that we have for studying or for understanding, say, logistic regression. We will look at the data available from the Titanic ship. This is the actual data from Titanic. So I'm sure all of you have heard of Titanic. This was the ship which went to sail, and it got drowned in Atlantic. This was in 1912. There were about I think 1300 or 1400 people on board, and quite a few people died, but obviously a few of them survived as well because of the lifeboat. So depending on the number of the lifeboats that were available, certain people survived, and obviously certain people did not survive. So we will be using this particular data set. Now, all these data sets that I'm working with, they are also available on the site at the same location that was given to you on Khatib classes site. All the data sets are also available there. You can download it directly. Okay, I'll first show you the data set. What exactly is the data set that we have? Now, if you look at this Titanic data set, it is an Excel sheet with how many? About, okay, 1310 values in all. So there were 1300 people on that particular ship. Now, what is the information that is available? You have the passenger class. So you have multiple values over here: first class, second class, and third class. So this gives you the different classes that the passengers were traveling in. So my first column is passenger class. Then you have survived or not, whether the person survived or not. 1 is where the person survived, and 0 is where the person did not survive. Then the name of the person, the sex of the person, age of that person. Then you have whether any sibling of that person was traveling on that ship. Then there is this patch, then ticket, or what was the ticket number, what was the fare that person had paid. In that particular ship, what was the cabin on which the person was traveling. Then you have embarked is what is the port from where the person had come on the ship. Boat, when the person survived, which is the boat that the person was taken on. Body, if the person did not survive, then the body was found or not, and the details of that. What was the destination that the person was traveling to? So this is the complete information that we have from that Titanic ship. Now over here, you can take up any question and you will try and implement a logistic regression model for implementing that. Now in our case, what we'll be doing is we will be looking at this particular column survived. So over here, I need to just try and answer this question, whether the person that we are talking about or whether the person in consideration, did that person survive on Titanic or not? So that is what is the answer that we are looking at. So this is what we need to do, right? So a P class, survived, name, sex, age, and then all these things. So this is what we are required to check. So this is the actual data set that we will be working with. Okay. Now going further, we'll try to analyze this entire data. Uh, just a second. Hypothesis testing is not required now. Okay. I'll get started with this particular code. We'll go step by step and we'll understand each and every step that is required to be implemented. Guys, again, I repeat, ML and AI is not about writing all the codes yourself. One, you're not required to do, and second, you'll not be able to do as well. But what we need to understand is that there are lots and lots and lots of tools which are available, which have been designed like with companies like Microsoft and Google and Tesla and Intel and so on. And you just need to know these tools and you need to know how to use them. That is what is the most important part. Now, this program you'll see again is a very lengthy program because we'll be doing a lot of stuff over here. But please understand this, that over here, entire logistic regression will actually get over in 4 lines or 5 lines. That's it. But the other thing, the data collection, data wrangling, data analysis, that is something which you need to do as per your requirements. Okay, let us get started. So now for implementing this, I'll start with the first set of data. What I'll do is I'll start by importing these libraries. I have pandas, matplotlib, seaborn, numpy, and math, right? So numpy, pandas, and matplotlib, these three are required, and that goes without saying. Anything that is required to be done in ML or data sciences or data analytics, pandas, matplotlib, and and numpy are always required. Math, depending on certain calculations that we plan to do, and seaborn also, when we try to implement any kind of metric, we might be required to use seaborn as well. Now, to start with, first thing that I do is on my computer at this location, see dataset titanic.xlsx. This is the location where the dataset has been kept. Now, two things. See, one is you create a folder, say called dataset, wherever on your computer, and put all the datasets inside that. So wherever you're keeping that particular data, you'll be required to give the path like this while opening that particular data. But if you put the program as well as the data set in the same folder or at the same location on the computer, just the file name is good enough. You're not required to give the path. PD is an object of class pandas, and pandas is used for retrieving the data from wherever into the program. Guys, the Python course that has been given to you, please go through data visualization, the concept, the section of data visualization from that Python thing, so you will know exactly how these codes will work, or what exactly is pandas doing, or what exactly is numpy doing. Please go through the data visualization part. That is the most important one as far as our sessions are concerned. It also has a case study. Go through that case study as well. If you've gone through the entire thing now, it will make understanding codes very easy for you. So what I'm doing is I'm just opening this particular Excel sheet and I'm getting the entire data into this data frame called data Titanic. Now dot head will just display the first 5 rows. So if I just run this much, it will just show me the first 5 rows of that data. So I know that the file has been opened properly. So it says 5 rows, 14 columns. So actually speaking, this data set has 1300 rows and 14 columns. So the total data that we are dealing with as of now is 1300 into 14, whatever is the set of value, whatever is that value. Okay. So what we've done is we've just opened that particular file and we've now displayed the data. Now, suppose if I want to carry out some analysis, depending on what you want to do, you will write this set of code. Suppose if I want to know what is the total amount of data in that particular file. So the function over here is length. Data Titanic is now the data set, which is now the data frame, which has all the data. When I go for length, it will give me the length of that particular frame, right? Then what I can do is, suppose if I want to count the number of people traveling over there, if I want to count how many of them were male and how many of them were female, we have a column called sex in that particular Excel sheet. What I need to do is I need to retrieve the data from that column sex, get it into a list, and then carry out a count on that particular list. So anything like counting and all is needed. You need to get the data from the data frame in the form of a list, and in that list what you can do is you can count whatever is needed. So what we do over here is data Titanic is the name of the data frame, sex is the name of the column. So whatever is the data, obviously there are 1300 values in that particular column, we will convert it to a list. The list is called as the sex wise list. Now in this, if I want to count how many entries are there for male and how many entries are there for female, so this is how we'll count this. See guys, this honestly has got nothing to do with logistic regression. It's just that whenever you want to apply say logistic regression, before that if you want to carry out any analysis, this is how you do it. Now when I run this particular code, yes, I'll be required to save it. I'll just save it somewhere. This is okay. So when I run this code, see, if you see, you'll find all this. So you've got this first 5 rows. The total number of passengers were 1309. Out of this, the number of male passengers are 843, and the number of female passengers are 466. So this is how you will get some aggregating functions like this, the count function. So it's not just about counting the number of male passengers, counting the number of female passengers. If you want to know how many people had come from a particular, how many people had embarked from a particular port, you can get that as well. How many people survived, how many people did not survive, or maybe how many people were traveling in first class, how many people were traveling in second class, and so on. So you can get something like this. So this is how you will go for data collection, depending on what is the insight that you want to generate, depending on what is it that you want to display. Accordingly, you will have to pick and choose. This is just demonstrating with just one attribute. You can add as many attributes as you want, whichever the attribute that you want from the data set, that is what would be used over here. Now let us try and get some plots. Again, this is still data collection. So first is data collection, data analysis, and then we'll go to data wrangling. Now observe this, what happens out here. Now, what I want is I want to create some graphs, some subplots or count plots. Now, over here, I'm using SNS dot. SNS is an object of class Seaborn. If you see, I had imported another library called Seaborn. SNS is an object of class Seaborn. Now, what I'm going to do is over here, I'm going to use the object-oriented approach for drawing graphs in Python. So over here, I'm going to get subplots, which is of the order 3 by 2. So you will have 3 rows and 2 columns. So in all, I'll be able to plot 6 different graphs. Now I want to come up with certain insights. So I'm planning to have 6 different graphs that are required to be generated. So that is what we'll do over here. Now observe this. How are we going to do this? SNS.count plot. So count is going to count the number of values in the attribute that we are working with, and then it will convert it to a graph, and then that graph would be plotted. Now suppose I'm going to this particular plot, which is survived, right? How many people survived, right? Now over here, when you talk of this 0 0, what exactly is this 0 0 that we are talking about? Understand? See, we are going to have a grid like this, which is actually going to have 3 rows and 2 columns. So my first graph will go here, my second graph will go here, my third graph, or ideally the word is the plot. This is what will go over here. So this is the row numbers, and this is the column number, something that we do for a two-dimensional matrix. So this is position 0 0, this is position 0 1, always row number first, then column number, then you have 1 0, then you have 1 1, then you have 2 0, then you have 2 1. So this is the position. So whenever you are plotting a graph, then you'll have to specify the position as well. So what we are going to do is the count plot function is going to count the number of entries that we have in a particular column, and then accordingly generate a count plot. So that is what we will be doing over here. So over here, what we do is we go to this column called survived, and then we will plot this as at position 0, 0. AX actually stands for axis. So when you say a plot, the actual graph, in Python we call it as axis, and this FIG that you see is a figure. A figure is basically a container. So you can say that I have created a container which called figure, which will have axis. How many of them? 6 axes inside that particular container. Now, if I just plot this much, see just the first line. So what it will do is, sorry, yes, there it is. See, see over here, if you see this first graph, I've executed the program till this point only. So it has got me the count. So 0 is the number of people who did not survive, and 1 is the number of people who have survived. So I'm not required to do anything. Just by looking at the graph, I can tell you that the number of people who survived were around 500, and the number of people who did not survive were around say little over 500. So the system will automatically plot all these things. Now, as I go ahead and plot other things, everything will then become obvious. So this is where I'm getting my count plot. System will take care of everything. It will plot things on its own. Now, similarly, suppose if I want to know how many men survived and how many women survived. So again, what I'm doing is I'm going to a count plot on the survived column, and now the parameter that I'm working with is X, and that is what needs to be plotted over here. So this will tell me how many people survived or how many people did not survive depending on sex, or how many men survived or how many women survived. This statement is going to give me the class wise, how many people were how many people survived were in class, first class, second class, and third class. See, because X is survived, everything is being plotted against survived. Fourth is embark, port wise. So if there are 3 ports from where people had embarked, say A, B, C, how many people from port A survived, how many people from port B survived, how many people from port C survived. So that is what it will show. So these are just some insights that I'm planning to generate. It's up to you to pick and choose what are the insights that you want to generate, and accordingly you will plot this. Now this is what is the graph that you are going to get. I think it is easier understanding here. The same graph I'll discuss from the PPTs. Okay, so this is the code that we are talking about. So immediately what happens is when we plot a graph like this, see, it'll give me a count. I'm not required to see the data. Around 750 people did not survive, and about 500 people survived on that particular ship. Now look at this. Now this is something which we'll be working with exhaustively as we go ahead. See, of the people who did not survive, 0 is who did not survive, 1 who survived. So second one is a sex wise data. So you will see say a blue color they've used for female, and orange color they've used for male. The colors have been picked up randomly. So if you see, over 600 men died and around say maybe 100 women died. This is the converse, right? Obviously, if there are more women who sorry, if there are men who more men who died over here, survival, less men survived, and say the people who survived more were women amongst them. So you get something like this. If you want it class wise, then the data is available class wise also. The number of people, just by looking at the graph, I can tell you that the most people dead were traveling in the third class, then the second class, then the first class. Or in other words, the number of people who survived the most were the ones who were traveling in the first class. Finally, embarked also, there were 3 ports from where people had embarked, S, C, and Q. Most people who died had embarked from this port S, and then few of them from C, and then few of them from Q, and so on. So this is how you can get the insights that you want to. So depending on what is the parameter that you're looking at, and depending on what is the parameter that you're checking against, accordingly you've got to change the value. So over here, when we are discussing these things, I'm precisely looking at stuff with reference to whether the person survived or not. So all the analysis that you are seeing over here, or all the analytics that you see over here, are purely keeping in mind whether the person has survived or not. So far what we've done is we've just opened the data set, we've just opened the data set, we've retrieved the data. Post that, what we've done is we've tried to find out the number of people who survived as male and female. Maybe sex wise we've got those analysis, or maybe if you just wanted the count with reference to the people survived based on the port, based on class travel, based on the port embark, based on sex, then this is how you do it. So this is where you can create data. You can do what is called as data collection and creating insights. Now the number of insights that can be created, that is endless. We can just keep creating whatever the insights that you want or whatever is relevant. Or maybe when we are working, say, for a company data, then what is the requirement that the company has? Accordingly, we can keep creating insights like this. Now what we'll do is we will now actually go ahead and implement what is called as data wrangling. Data wrangling is something which needs to be understood properly in this particular data set, because when you get a practical data set, there are a lot of flaws in that data set, and if I don't rectify, if I don't analyze and eliminate those flaws, you will never be able to get the prediction model. See, understand this, guys. See, when you're creating a prediction model, if that prediction model is working on the data that is not well defined, or if it is working on the data where a lot of data is missing, or if it is working on the data, or if it is working on the data where the data is sporadic, then in that case you'll not be able to get a prediction model which is accurate enough. So how exactly that has to be taken care of, that is what is the next part of our discussion. And once that is done, we will be all set to get into what is called as the implementation of the logistic regression model. So that is something which is coming up now. But any doubts with whatever we've discussed so far? Any doubts pertaining to whatever you see on screen or any concept that we've discussed so far? Okay. So it is always the data engineer who has to decide what are the insights which are required to be generated, and that will obviously be based on whatever is required by the company. Now comes the data wrangling part. Now, guys, just look at this, and I'll introduce heat map to you, and we'll also discuss the importance of heat map in machine learning. Right? Observe this. Now, over here, I'll display some information from this. See, where is my problem? See, look at this data set. If you look at this column, say sex, you have 1300 entries for everyone. That is all right. That is great. So there cannot be any problem whenever I'm using the data from that column. But look at this particular column, say age. What you will find is that there is certain data which is missing. So some data which is missing. This is not available. So there are some entries missing, right? So, but not many, but still there are certain values and missing. Now look at this. If you look at this particular column, say boat, see, if you see lot of values are missing, right? Over here we have a lot of values missing, and then you have this column body, and again you will find a lot of values missing in that particular column, right? In this particular column, which is say home destination, again there are certain values missing. Now what this means is this actually reflects the lack of data, or you can say the availability of data. Now imagine if I'm creating a model which is relying so much on this particular data, and what I find is that a lot of data is missing like this, or what I find is that so many entries are missing like that. So it's like I'm drawing a curve where so many points are missing, then obviously there will be a problem. So what I need to do is I need to first try and understand how do you take care of all this missing data, right? Because it can induce a lot of errors in the model that we design. So what we are starting now is what is called as data wrangling. Data wrangling precisely means cleaning of data. So whenever you design any model, not just logistic regression, whenever you design any model in machine learning or AI, you should always first have a look at the data. You will have to analyze the data, figure out where exactly the issues are, and then you will try to wrangle the data, or you're required to clean that particular data. Now over here, I find two major problems with this data set that I'm working with. Now there are certain columns which have a lot of missing data, and then every column will have little bit of missing data. Now what I need to do is I need to just figure out what needs to be done. See guys, 1000 or 1300 values are no big deal. Also this data set, just by looking at the values, just by looking at this Excel sheet, it is very obvious for me what is the column where the data is missing, or what is the column where you have too much of missing data. But imagine if I have a data set with say 1 lakh values. Suppose this was an Excel sheet with 1 lakh values, and there were say about 40 columns, 40 different attributes that we need to look at. See, one simple thing. Suppose if I talk of say the transactions that are happening on Amazon per day. Now you can imagine globally, or forget globally, even in India, the number of transactions that will happen on Amazon every day. You can imagine the number of entries. If there are a million transactions happening on Amazon every day, then I'll get for one single day, the number of entries would be 10 lakhs. And the number of items, what? Now there are thousands and thousands and thousands of items available on Amazon. And if every column is representing the data, you can imagine the number of columns that it will have. So this can be really massive. So we can't just rely on just looking at the data set and coming to a conclusion that, okay, these are the attributes where there is a problem, or these are the attributes, or these are the columns where there is a lot of missing data. How do I do that? How do we tackle that? That is what we'll now try and understand. Now, please, I repeat, whatever we discuss in the next 15 odd minutes is something which is applicable to all of machine learning and AI, and not just logistic regression. Understand, we haven't still started with logistic regression. What we are talking about still is data wrangling, cleaning up of data. So all these steps that I'm doing, working with any model, you need to analyze the data first and then carry out these steps before you actually go ahead and design that particular model. Now observe this. If I want to display the information and is null function, now understand the purpose of this is null function, and understand the function of this sum function. This sum function is actually an aggregate function. If you look at my code, data Titanic is the name of the data frame which has the entire code. Dot is null. This will return all those rows where the data is null, right? And sum is, this will give me the count of null values. So it is just picking up the null values, that means missing data or empty data, and what is the count, that is what is going to get displayed. So now if I just run this code, see, this is something. See, this is something which is displaying the info. Now it is up to you, if it is up to you whether you want to display this or not. Wherever the data is not missing, it will write false, and wherever the data is missing, it will write true. So this is just displaying you the entire data, and it will tell you what is null or where the data is null. But again, see, understand, if I display just something like this, this is not going to help you in any given way, because what's happening out here is that there are too many entries. Just by looking at this, I may still not be able to figure out what's happening over here. The important part, or the important attribute, or the important statement is the last line where I get the sum. Now looking at this, what it tells me is that there are 1309 rows and 14 columns, out of which I have 0 missing data in these 4 columns. There are 263 values missing in this column age. There are 1014 values missing in cabin. There is 1 value missing in fare. There are 2 values missing in embark. There are 823 values missing in boat. There are 1188 values missing in the body, and so on. So straight away, what I'm getting is I'm getting the number of values missing in each of the columns. I'll get the values like this. So this is one way of doing it. But the best possible tool for understanding, or the best possible tool that you have for data wrangling in machine learning, is a heat map. Now, what exactly is a heat map? See, whatever numbers that you see over here, what I'll do is I'll plot a heat map for this. Let me just get the heat map first, and then we'll understand the purpose of heat map, and then we'll highlight the importance of heat map that we have. Now, understand, when we run this, this will go, and I'm plotting this heat map on the same axis, right, at position 20. Now, this is the heat map that we've got. Now, again, let us try and understand what this heat map is all about, and why is it that we are going to this heat map. So over here, I've created heat map. Currently, the program that I've demonstrated so far is still this line. Now just observe this. What is this heat map? This is where we've zoomed that image. See, what this heat map does is, this heat map is plotting all the columns that we have. Ideally, if the data was clean, I should have seen like this. What this means is that there is no missing data. Now, wherever you see these yellow lines, what this means is, or this is representing, is the missing data. So if you see, there is a lot of missing data. in this particular attribute called body, in this particular attribute called boat, there are a lot of missing data here. There is quite a few missing data over here. If you see, there is an odd value missing in fair. So this is less of missing data. There is lot of missing data. So the moment I plot the heat map, the map gets created in such a manner that just by looking at that particular map, I can straight away tell you what are the attributes where you have too much of missing data. So this is what we find. So I'm interested in looking at these yellow spaces, and I don't like too many yellow spaces, because what that will indicate is that it represents missing data. So there is too much of missing data in certain columns. Now if you look at, say, columns like, say, body or boat or cabin, see, there is so much of missing data. Suppose say 70% data is missing. Imagine I go ahead and create a model using an attribute, using a feature where 70% of the entries are missing. So you can imagine what would happen to the accuracy of that particular model. So that is something which I don't like. So now over here, I need to design a strategy about how do we clean this particular data. I'm not liking these yellow columns that I see over here. How do I clean this particular data? Now, when you talk of data wrangling, or when it comes to handling missing data, there are two approaches to it. There are two different ways in which you can do this. Now, what are the two approaches? See, first is, see, all these columns that have too much of missing data, like this, all these columns where you have too much of missing data. See, if 70%, 80% data is missing, I cannot just try and figure that data out, or I cannot replace that data with something. So all these columns where too much of data is missing, we will straight away delete those columns. Or you can say the right word is drop. In SQL, we use the word drop for dropping a particular entry from the data set. So what we'll do is we'll drop all these columns. So the columns will be dropped straight away, because I just can't do anything with those columns. I cannot use it for generating any insights, because there is too much of instability. There is too much of missing data. Now, this is one part. Now, how about a column like, say, fair, where you have, say, few missing data? See, out of say 1300 entries, say 4, 5, 7, 8 values are missing. Then obviously I'm not going to drop a column with those missing data. But what do I do? What do I do with the values which are missing? So suppose if I have a column which has, say, 3, 4, 5, 6, and so on, say 10 entries. Out of this 10 entries, say entry number 3 is missing, entry number 6 is missing. What do I do? What I'll do in such a case is, see, this is hardly two values, say, out of 10. See, 20%, it's still high, but what I'm trying to say is that the number of values missing are not too high. Then what do I do? What I'll do is, of all the values that we have in this particular column, I'll take the average. So of all the 8 other values, suppose the sum of all other values has come out to be, say 80, and the number of values are 8. Right. So out of the remaining 8 values, I'll divide this 8 divided by 10. 80 divided by 8, the value is 10. What I'll do is I'll replace these missing values with the mean of all the remaining values in that column. So this is what we do. So two approaches to data wrangling, or two approaches to data cleaning are: the first thing that you do is you first delete all the columns. You first delete all the columns that you first delete all the columns that you have in that particular data set where too much of data is missing. And second is you just replace those values where little bit of data is missing. You just replace those entries with an average of all the other entries that you have in this column. So these are the two steps. So what I'm going to do is, whatever steps that I've spoken about, I'll apply those steps. And once I've applied that, immediately if I display the heat map will come out like this. So guys, please understand this: whenever you are creating a heat map for machine learning or AI algorithms, it has to look like this, but practically it will not happen. Practically it will look like this, or maybe slightly better than this, but then you got to decide what are the columns that you want to drop, what are the columns where you want to replace the values with the average value of that particular column. So also this is for you as a data scientist to decide, okay, I'm okay with 10% missing data. So out of say 1300 values, if there is a column which has say 100 values missing, so which is less than 10%, so you can say that okay, this is okay. Anything greater than 10% is not acceptable to us. See, I'm not saying that this is a rule that it has to be 10%. See, depending on the data that you're working with and depending on the criticality of that particular column. See, sometimes what happens is there are certain columns where the amount of data missing is 20%, but depending on what you're trying to do, that column is so important that it cannot be dropped. Then even though I might see something like say a yellow bar like this, I still will not be in a position to drop that particular column. So there cannot be a single rule for data wrangling. It purely depends on what is the data that you're working with, what are the insights that you're required to generate, and what is the amount of missing data in a specific attribute. So that is what we are required to do. So now I've got this particular heat map. Now, if you look at this heat map, observe this data Titanic dot is null. Wherever the data is null, that is what has been plotted, right? Over here, white tick labels is equal to false. So what this is doing is, if you see, I've not plotted anything on the y-axis. I'm okay with just the x-axis. C map is basically the color. Viridis. See, there are two options when we work with heat map: Viridis and grayscale. So had I gone with grayscale, this graph that you see, which is purple and yellow, you would have found it as black and white. That's it. And then this is the position on the axis 20. Now what I'll do is I'll implement all those steps which will implement data wrangling. See guys, all the comments that you see over here, everything is there in the PDF. So there is a proper documentation. So the explanation of every line that you see over here as comments, it's there in the PDFs as well. So whatever we are discussing, the everything would be there on the PDFs. Now, what I'll try and do is I'll try and drop the column. We know that in Python, we have this command called drop, using which I can drop the data from the data frames. Guys, please understand this. See, my data set is called as Titanic.xlsx. This is my Excel sheet. Over here, I've got that particular data in this data frame called data Titanic. So data underscore Titanic is the file in my program, which contains all the data, that you have in that Excel sheet. So when I say I'm dropping the columns, or when I say I'm deleting something, please understand I'm deleting it from my data frame. That is what I'll be working on. I'll not be deleting anything from the Excel sheet. You cannot do that, because that is the client data, and if you do that, the change is permanent. The data would be lost. You can do whatever you want with the data frame, but please, you cannot go and delete everything that you have in that Excel sheet. So even after the completion of this program, even though everything would work fine, you will see that I haven't touched the Excel sheet. I'll do whatever I want to the data frame, which is the replica of that Excel sheet in my program, which I've stored in this data frame called data underscore Titanic. Now this is where we will start the cleaning part. Observe this, how this has to be done. So this is how it is going to work. This is where I'll try. Okay, let me just put a comment here. This is data wrangling. Actually, data wrangling has already started, but this is where I'll drop this. Now observe this. See, I need to drop certain columns. I'm planning to drop say 5 columns: body, cabin, boat, home destination, and age. These are the columns that I plan to drop, because there is too much of missing data. 70-80% data is missing and I can do nothing about it. So what do? Data Titanic, this is the name of the data frame, dot drop. What is this drop command doing? It is dropping that column from the data frame. I repeat, I'm not touching the Excel sheet. I'm just dropping that column, which is the column body. Axis is equal to 1. See, when you work with graphs in Python, axis is equal to 0 refers to row, and axis is equal to 1 refers to column. So when I write axis is equal to 1, I'm actually referring to the column, or you can say I'm dropping the column. In place is equal to true. Now what in place will do is, in place is equal to true means that you drop it permanently. So from that particular data frame, that column is dropped permanently, right? If I keep it false, what I can do is, for the time being, I can just eliminate it and then see what's happening. But the column will stay in that particular data frame. It will again be participating in whatever is the code that you're writing further. But moment I say in place as true, what that means is, from that data frame, this column called body has been dropped immediately. So this is the name of the column. This is telling the system that this is a column. If I put axis as 0, wherever I find certain entries, it will start deleting that, right? And then in places too. Similarly, I've dropped this column cabin, I've dropped this column called boat, I've dropped this column called destination, and I've dropped this column called age. And now if I plot this heat map, it will plot this heat map. And then still, if you want to see what is the sum of the number of values missing, so I'll do that as well. So now you will see a different heat map altogether. So the heat map that you're going to see is the one which is now created after cleaning of data. Observe this. Now this is the heat map that we find over here. Now if I show you this same heat map, this is the one that we've got just now. After wrangling, this is the heat map that you have. If you see in the first heat map, if you see in the first heat map, there are so many columns over here, but over here, a lot of columns have gone missing. Which are the columns that have gone missing? All those columns where you had too much of data missing. That is what has been eliminated. So we now have a clean data. Maybe an odd yellow here and there you might find practically when you're working, but that is okay, right? But I'm pretty happy with this data. This was absolutely not acceptable to us, because the model, it would have caused havoc. So much of missing data would have caused havoc in that particular model, right? So that is what we have over here. Okay, now back to this. So if you want to see the sum, now you will find the sum as well. See this. Now you will find that these are the columns remaining. There is this column called fare, which has one missing data, and there is this column called embark, which has two missing data. This is still okay. Rest everything, whatever columns I'm left with is, you don't have any missing data. That is why you saw that the heat map was almost entire thing was purple, because there's hardly any missing data. So comparing the heat maps, just by looking at the heat maps, you can see, or you can conclude whether the data is clean or whether the data needs wrangling. Guys, please understand this. Machine learning, you will have ready-made functions, you will have ready-made tools. What the developers are telling us is that you just give us clean data in the format that we want. Rest everything we will do. See, when we work with linear regression, we saw a function called fit, we saw a function called predict, right? These same functions you will keep coming across all the times. If you get the trick of machine learning, what you will understand is that you have to just import a particular library, and the same 2 3 functions are required for doing everything at all times. The key is how well can you do data wrangling, and how well can you organize the data because before it is fed into the system. If the data that is fed into these functions is perfect, you will get some awesome results directly. So that is something which you are required to do whenever you're working with any machine learning model, data wrangling. So that is what we've got over here. So I've got the data cleaned over here, right? Now what we need to do is we now need to make some changes to the data. Now this is where I'm starting to implement whatever is needed for whatever is needed for logistic regression. You can say to an extent I've got the data wrangling done. There is still one part which I'm still to discuss, which is related to data wrangling, but what we have discussed so far is precisely data wrangling. I'm now planning to get started with the logistic regression thing. Any doubts with whatever we've done so far? Have you all studied logistic regression before? Anything? Also, guys, what I've tried to do is I've tried to keep my codes in such a manner that very few part. Rafi, I'm still to come to that point. I said that I have to take care of that. So that meanwhile part is still to be done. We'll come to that. We'll come to that. See, what we try and do is we try and keep the codes in such a manner, like logistic regression ka code that I'll be writing now, or maybe say support vector machine that we'll be seeing later today. I'll try and keep writing the codes in such a manner that they are not specific to the program. So what you can do is, once you have all these programs with you, you just pick up any particular data. Don't touch that code given to you. Just change the input that is being given and you'll get the desired results. And honestly, that is what literally I do. I have all these programs, the soft copies of all these programs with me, all these models. If you ask me to design, say, a model, say a support vector machine for some particular data, it's not going to take me any time. The reason is the codes that I have with me are the support vector machine codes are which we've kept generic, which has got nothing to do with the program. All I'll do is I'll just change the input data to whatever is the data that you've provided me. I'll just wrangle that particular data and pass it, and I'll get the models done. And that is how it literally works. And that is how the programming is going to happen in future. See, in future, it's not going to be the way we program these days. See, all those who studied maybe say 15 years back or something like that, we all started studying with Pascal and C language. We were taught to do the donkey work, to write logics for everything. That is not how programming is done today, and surely not happening in future, because what we are looking at for future is functional programming language. What that means is that you don't have to implement logics for everything. You will have the tools. All you need to know is which is the tool to be used where. That's it. So that is what is going to happen in years to come. And all new programming languages, if you look at R programming, if you look at Go programming, all these programming languages are working like that. Microsoft is the biggest supporter of functional programming. If I don't know if anybody over here, if you're working with say softwares like Selenium and all, if you're working with testing softwares, they are all functional programming languages today, and that is what the future is all about. See, I have no shame in admitting if I'm working on anything related to Python, machine learning, on AI. When I design a system, my 90% time will go on Google. I just need to figure out what are the tools. Just 10% is enough for me to implement that particular tool. And literally every day new tool comes up. So you have to keep searching. You just cannot remember, or there is not one resource where you can go and you can find all the tools. Just keep Googling. Literally every day you will find new tools. So that is the approach that we have. Okay. So now that we've got this data wrangled, now that we've got the data cleaned, what do we do next? Please observe this. So now we will start by converting the data to categorical. Now this is something, guys, which you need to understand properly. What exactly am I trying to do? And then I'll show you how is that going to help us. So now, observe this. See, guys, when you go to a data set, there might be some data which is categorical. There might be some data which is non-categorical. When I say categorical, I mean 0 or 1, true or false. If you see survive column, this is already categorical. This is already categorical. But if you look at this column, say sex, it has string female, it has string male. It is not a categorical data. So I want to convert it to categorical. Then maybe any other column that I want to work with, then I would want to convert it to categorical. Now, how do we do that? Please try and understand this. I'll demonstrate this with one attribute, say age. Now, what is, say sex. Now, what is going to happen? See, in this case, what I'm doing is I'm creating a new list called sex categorical. Now, what is this? I'm using a pandas function called dummies. What this will do is pd.getDummies. What this will do is it will replace the entire data in the column called sex in this data frame called data Titanic. It will convert it, or it will replace it with dummy values. Now this line number 41 is actually not needed because not needed because when I'm designing a model, I need not display too many things, but I've displayed this over here just to show you what exactly is happening with that statement. I've replaced it with dummy values. So just observe what happens. See this, what has it done? It has converted it to dummies. Now what is this happening? Female and male, you've got these column like this. Now I'll just try and give you what exactly has this dummies column done, and then we'll see how are we going to use it further. See this, please understand this, please. Whenever you are working with a model like logistic regression where a lot of data needs to be categorical, what we discuss again in the next 10 minutes, this is something which you are required to do all the time. This is something which you'll need big time. See, as of now, what do I have in my data set? Observe this. I have, say, suppose this column, say, called sex. Suppose there was this first person who is categorized as male, second person was also male, third person, say, is female, fourth person is, say, male, and say fifth person is, say, female. These are the entries that we've got. Now, when I convert it into categorical data using the pandas function called dummies. If you saw, I said pd.getDummies. What that will do is it will go to this column sex. It will check what are the entries available over here. See, I still have information about 5 people. Guys, please listen to this very carefully. I still have information about 5 people, right? So over here, it will say, it will create this column called male. It will create this column called female. Now over here, if the first person was male, it will put 1 over here and female as 0. If the second person was male, this is 1 and this is 0. If the third person was female, so this is 1 and this is 0. If the fourth column was male, so fourth entry was male, so this is 1, this is 0. If the fifth entry was female, you will get something like this. Now this is what get dummies has done. Now over here, because in that column there were only two entries, say male and female, that is why we've got 0 and 1. If suppose I was working with some data, say suppose embarkment, suppose there were four ports from where people had embarked, right? A, B, C, D. So what it would have done is it would have gone 0, 1, 2, 3. So what it does is, depending on the number of entries, number of unique entries that you have, accordingly it will replace it with dummy values. Over here there were only two entries, male and female. That is why I'm getting 0 and 1. So what I now need to do is when I want to check whether the person that we are talking about was male or female, what I'll do is I'll just have a look over here. So over here, say first person, this is 1, that means the person was male. Second person, this is 1, so this person was male. Third person, oh no, this is 0, that means the person was not male. Fourth one, yes, male. Fifth, not male, and so on. So I've got this data like this. So one, I'm not required to process any entry. So text is gone. I've got the data in categorical form. But guys, please understand this. Over here, I've got two columns. One is for male and one is for female. The argument over here is, see, suppose if for the first person is male, second person is male, third person is 0, that means the person is not male. So by default, it will any which ways imply that the person is female, or vice versa. First entry. If I get this first entry for female as 0, that implies that the person was male. Huh? So the fact is, to determine whether this person was male or female, I don't actually need two columns. Because if I can conclude that this person is female, then job is done. If I can conclude that this person is not female, it any which ways implies that the person was male. I don't need two columns. So what I'm going to do is, guys, one, I've converted this to categorical data using pd.getDummies. That is what getDummies function has done. And now what I'll do is I'll actually drop this first column, because I don't need that column called male to actually conclude whether the person is male or female. Just one column is good enough for me. Suppose if this column female is retained, then wherever the entry is 1, that means the person that we are talking about was female. If it is 0, that means the person was male. So when you say that you are converting the data to categorical, you need to first get dummies, and once you get dummies, you need to just eliminate the columns which are not required or which we can do without. If you say no, without this we will not be able to work, you can always keep it. That call is always yours. But guys, practically it does not happen. The idea of converting it to categorical is that I will be able to represent it like that. So if you see, I've got this data in categorical form. Now that I've got this data in categorical form, what I understand is, yes, Gary, you can keep either of the columns. It's up to you. So what you will be able to conclude is, if you keep the column, say male, so you will know the person is male, the person is not male. If you keep the column as female, it will mean that the person is female, the column else the person is not female. That is what it will mean. So what I find is that I've got two columns over here, male or female. You can drop either of them. If I use, say, drop first, it will drop whichever is the first column in this list. Now in our example, it has got say a female as the first column, so that particular column will then get dropped. So how do we do that? If you see this, see, 6 categorical pd.getDummies, what it does is drop first is equal to true. What do you mean by drop first is equal to true? When I write drop first, what it means is, after you've got the categorical data, whichever is the first column, you just drop it. For me, it doesn't make a difference whether you drop the male wala column or whether you drop the female wala column. The number, the data that I'm processing or the entries that I have will still remain the same. The conclusion that I'm going to get is still remain the same. Now I've displayed this X categorical again. If you see, guys, observe this earlier. Where is it? Yes, see this. I had two columns over here. This is what happened when we converted it to dummies. And then after dropping, I'm now left with just one column, which is male. The column female has been dropped. So what you'll do is you'll convert the data to categorical and then you can just eliminate them. Guys, I'm just displaying all these things just to show you what has happened. But when we actually design the model, these all things need not be displayed. I've displayed too many things over here, and that is something which you will find in all the codes that I write, because it will just help you see what's happening for understanding the code. But when I'm designing the model, I'm not going to be displaying any of these things. I don't need to, because see, the end user is only interested in the results that the model is generating. They're not interested in these steps per se. So that is what we've done. Now, other data which needs to be converted to categorical. Now it's up to you. Whatever is the data that you want to convert to categorical, you can just convert it, and then decide how that has to be used. So there is one more column. So say embark. So what I've done is I've converted it to categorical and dropped the first column. Same thing I've done with say a P class as well, right? So that is what we have over here. Now, observe this. I'll demonstrate the same thing with this P class. What exactly has happened in P class? See, now again, suppose there are 5 people, 1, 2, 3, 4, 5. The column is P class. The first person was traveling in second class. The second person was traveling in first class. This fellow was traveling in first class, and the remaining two were traveling in third class. Right? Now, when I convert it to categorical, what happens here is 1, 2, 3, 4, 5. See, this is first class, this is second class, and this is third class, something like this. Now over here, this person was traveling in second class, so this becomes 1, this is 0. The second person was traveling in first class, so this becomes 1, this is 0. Third person was traveling in first class, so this is 1, these are zeros. Now the fourth person was traveling in third class, so this is 1. The fifth person was also traveling in third class. So this is what I'm getting, right? Now guys, observe this. Once I get these 3 columns with me, what I understand is that, say, for this first person, I find 1 over here, so the person is, say, in second class. 2, I find it over here, so the person is in first class. 3, I find it over here, so I get this. I get this person is in first class, something like this. This is what we'll do. But again, observe this. Observe this. This says that the person is traveling in second class. This says that the person is traveling in first class. This says that the person is traveling in third class. Now, assuming that I have only these 2 columns, second and third. So if I find 1 here, the person is traveling in second class. If I find 1 here, that means the person is traveling in third class. If both these values are 0, wouldn't that imply that the person is traveling in the first class? So over here, after converting it into categorical, I had 3 columns. Now, if I drop this, my job is still done properly. My job is still done. What is happening over here is I will now have 2 columns for second and third. If both are 0, that means the person is traveling in the third class. In the first class. So guys, when you convert it using get dummies, and when you start to drop, the system will automatically take care of this. Over here, there were only 2 entries when I converted to categorical, male and female. That is why I got 2 columns. There were 3 unique entries, say first, second, and third class. That is why I'll get 3 columns. But accordingly, the system will adjust it accordingly. The system will work with whatever is needed. So this is how it works out here. So if you see, that is what we've done over here. Now suppose if I now get this, say, embarked, if I display embarked categorical and P class categorical, it will show you what has now happened after converting the data to categorical. Now observe this. This is what I was talking about. All 1300 values, which is the column. See, we only have second and the third class. There is no column for the first class because the first class wala column has got dropped. Similarly, there were 3 ports of embarkment. I think there were C, Q, and S. You find only Q and S. The first one is dropped. So wherever both the entries are 0, what this means is that the person is actually traveling in whichever was the third category which was available. So we have converted the data, whatever needed, into categorical form, which is into zeros and ones and true or false. So for doing that, we'll make use of get dummies, and we will use this drop function. Now guys, observe this. From the data set, what I've done is from the data set, see what is my original data set right at the beginning. See this. See, this is the data set that I have. P class, survive, body. So I have all these things. Now what I've done is, out of this, I've dropped certain columns, so that is okay. But there are certain columns which I've now converted to categorical. So guys, say the column sex is still part of this particular database which says male, female, male, female, male, female. Now I've converted that to categorical, and we saw that there is one column remaining which is called male, which is good enough for us to understand whether the person traveling was male or female. So what I'm going to do now is, whatever is the new column that I've created, say male, I will add that to this data set and then delete the previous one which had male, female, male, female. So I'll drop that particular column. Guys, understand this. This column is still there. We just saw that I've now converted the data to categorical, where I have this. Now I don't have a column say called sex. I'll have a column called say male, which will have entry 010101. What I'm going to do is I'm going to append. Append means adding at the end. I'm going to add that new column. Sorry, this is not append. For a data frame, it is concat. Concatenation is joining. I will add that column into this data set and then drop or delete this particular column. I don't want say multiple entries for trying to figure out what was the sex of the person who was traveling, or what was the sex of the person who survived or who did not survive. So that is the code that I'm going to get now. So far what I've done is I've got the data in categorical form, and now this categorical data would be added to the data set, and the other data which was not non-categorical, which was available, I will now drop it. I will now drop it. I'll just demonstrate it with one column first, and then I'll go to the other columns. Observe this. Now, data Titanic is pd.concat. All these functions belong to the library pandas, right? pd.concat. What am I doing? The file is data Titanic, and what is the column that I'm adding to it? Sex categorical, embark categorical, and p class categorical. This is what we've added. Axis is equal to 1. That means add all these columns. So all these new categorical columns have been added. Now, once we've done this, the earlier columns that we have, they need to be dropped. So now I'm dropping these columns. Sex, embark, name is not needed. It is not going to help me. So I'm dropping that as well. See, actually, there is one more column, ticket. Or the ticket price. We might not be needing that also. So we can drop that as well. But then I've kept it for a purpose, right? So this is P class. So all these columns have been dropped. Access is equal to 1, in place is equal to true. Now, if I show you the new data set that happens after all this processing, observe this. See this. See my original data set or the original data frame. Where is it? Where is it? Where is it? See, my original data frame was this, which had class, survive, body, home, destination, all this. Now, if you ask me that what is the data set that I've got, my data set now looks like this. So this is survived, whether the person has survived or not part. Now you have this ticket, fare. See, if you see, these are the columns. Now look at this column, male, Q, S, 2, 3. So these are the categorical data that I've got, and I've concatenated them to the data set, and my other columns have been dropped. So the columns, I see over here, there is no missing information. It's just that now I've represented the same data in categorical in categorical form, right? So what happens if we have more than 3 in a single column? See, it doesn't make a difference. Shoaib, if you have say 4 columns, see, that is what I was trying to demonstrate here. यहाँ पे जो अपन ने किया है, look at this. See this. See over here, if there were 2 values like this, I had got 2 distinct columns, and then I dropped one. When I had three unique values, so I had got 3 columns and I dropped. If there were 4, I'll get 4 columns like this, and then one of them will be dropped. I will any which ways not be required to have any additional column, because what I can do is 0, 1, 2, 3. I can have values like that. So if there are 4 values, it will be 0, 1, 2, 3, and then accordingly the system will work. Also, see, understand this, even if you don't drop, it is not going to hurt you in any given way. So we just try to keep the data minimal, but honestly, even if you don't drop, it doesn't make much of a difference. We can have both these categorical data. Say even if I retain column male, or even if I retain this column first, it doesn't make a difference. It will not make much of a difference to the final model. Okay. Uh, Guys, in this next step, what I'm going to do here is I've got this particular column called survived in this list called y. Now, why is it? See, whatever is the model that we are designing, we'll have some data on x-axis, some data on y-axis. Y is the the dependent parameter. So I'm going to answer, say, whether the person from this port did they survive, whether the person of this sex did the person survive. So my answer is going to be survive. So what I need to do is I need to get that. So I've got this entire data in this list called y. So all the entries from this column survived. I've gone to this particular list y, and what I'm doing is from the original data set, I'm just deleting this particular column called survive. So this is not going to be there in the model that I design. This is going to be the answer that I'm going to get with reference to the data which is available in this data frame called data Titanic. And I'm also dropping one more column, which is ticket. So that is what has been dropped. So now if you display this, what you will find is you will find that the column survived has been deleted from the data set, and this is the final data set that we are left with, something like this, right? 1309 rows. We haven't dropped any rows as yet. So that is what we've done. Now we are pretty much done as far as the data wrangling part is concerned. Now what we need to do is we need to go ahead and we need to implement your regression model. Is this understood so far? Wrangling is done. We need to go ahead and implement logistic regression. Any doubts with whatever we've discussed so far? You can put it in the chat windows, or you can unmute and speak, either ways. Gary, what exactly? What part? See, whenever you're drawing a graph, there are two things, X and Y. What you plot on X is the independent parameter, and what you plot on Y is the dependent parameter. Now, suppose if you're asking in terms of, say, male and female, and I want to answer whether men survived or not, or women survived or not. So survived is going to be. Now imagine if I keep survived here also, will this work? So any answer that I need to pick up should not be here. So what I'm going to do is I'm going to create a list called column, which will store the data from survived, and I'll delete it from this X. So X will basically have all the attributes except for survived, and Y will have only survived. So that when I pass it to the model, the system knows what is the value that goes on the Y-axis, or what is the independent parameter, and what is the dependent parameter. So that is what we've done over here. Kidhar gaya? So over here, I've just got this column survived in the data from column survived in Y, and then I've just dropped it from X. So I've got X and Y. Now this is done. Now the next thing that we do is now my actual logistic regression will start. Now everything in logistic regression you will see will get over in hardly 10 lines. Sure, we'll come to that. I gave you one part of data wrangling, which was dropping the column. I'm still to come to the second part. So this is where your logistic regression will actually start. Now this is where I'm going to design the model. Data wrangling is now over. So how do we do that? Now, see, Now, this is something which you need to understand properly. Again, something which you'll keep doing all the time in all the models. From scikit-learn.model selection, import train test split. Now, what is this train test split and what are we going to be talking about? Now, again, something that I discuss now is going to be relevant to each and every model that we are going to design, right? Now, guys, just understand this, please. See, what I need to do is I need to create a model based on the data that you've given me. But then how do I know that the model that I've designed is good, or how do I know that the model that I've designed is bad? How do I test it? This library called scikit-learn provides us with the tools for doing that. Now, what exactly is happening? Just understand the logic first, and then I'll show you how exactly that is being done in the code. See, suppose I have some data with me. Suppose I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose I have 10 values. This is the value of X and this is the value of Y. Okay. Now suppose the value of X is 2, Y is 5. I'm just putting some random values. Now suppose I'm designing a model. My aim is that you give me the value of X and I'll give you the corresponding value of Y. This is what is the model. We are designing this. Suppose I've just designed a model using the data that you've given me. But then how do I know that the model that I've designed is good or bad? Or how accurate is it? See, because what I know is, see, I am designing a model based on the data that you've given me. If your data is great, the accuracy of this model is going to be high. If the data is not consistent enough, then the accuracy is going to be bad. But my aim is, whenever I'm giving you a model, if I tell you, okay, this is the model, I will say that this model is accurate to say about, this model is say accurate to about say 60%. Or I'll say that this model is accurate to say about 20%. It's not about the values. See, if my model that I've designed is accurate only to 20%, that doesn't mean that my model is bad. What it precisely means is that the data given to me was such that I could design a model which could be accurate, say to 20% only. See, what happens is, if you're using a model, right, if you're using a model, you should know to what extent should you believe that particular model. Like what a company does is, if they are manufacturing a car, they'll say that the mileage of this particular car is 15 kilometers per liter. See, I'm not saying that once I get that particular car, when I drive it, and say if I put 1 liter petrol, it will go exactly 15 kilometers. No, it might maybe drive 13 kilometers in a liter. It might at times drive 16 kilometers in a liter, but I actually get an indicator, okay, this will go approximately to about 15 kilometers. Now if I feel that 15 is too less for me, I'll not buy that car. As simple as that. So whenever I'm designing a model, depending on the data that I get, after I've designed the model, I need to test that particular model. And based on the test result, I need to tell you what is the approximate accuracy of that particular model. Now, whether it is acceptable to you or not, whether you want to use it or not, that is your problem. I can't help it. I can design a model based on the accuracy of the data that you provide. So it's not that if I've designed a model which is highly accurate, then I've done something great, or maybe if my model is not too accurate, then I've done something bad. No, it is basically an indicator of the data, as simple as this. But the question is, if I've taken this entire data and I've designed the model, how do I check the accuracy, or how do I even tell you how good or bad this model is? Now, what we do is, the logic goes something like this. What scikit-learn will do is, see, whatever data you give me, suppose you have given me 10 values, I will divide it into 70-30 ratio. 70% data would be for training. So I'll say that this is my training data and this is my testing data. So what I'll do is, when I'm designing the model, I look at only these 7 values. So using these 7 values, I have understood that, okay, if you give me the value of X, I'll get you the value of Y. So my model is now ready. So this is the training value for X, I'll say this is X train or train X. This is Y train. This is the values of Y that I'm using for training. Now what I need to do is I need to check how good this particular model is. See, if I want to know how good or bad this is, I need to have some reference values. Now I'll go to this 30% of data. I know for the existing value of X as 6, the result is 3. I call this as X test and I call this as Y test, something that you will do in almost all models. Please understand this. I know that the value of input, if it is 6, I know the actual answer is 3. What I'll now do is I'll take this testing data. I'll give the input as 6. Suppose I should have got my answer as 3 and I'm getting my answer as 4. So expected answer was 3. For 6, expected answer was 3. I'm getting 4. Let me check the next input. Suppose the input given was 4. I was expecting the value of Y as 6. I know that the answer is 6. And say suppose I'm getting 6. So for the next entry, this was 6 and this is also 6. Then I'll take this and then I'll take this. I'll give the input as 9. I was expecting the value as 10, but say suppose I'm getting 8. So this is 10 and this is 8. So what I'll do is of the data given, I will take 30% of that data only for testing. Now, when I'm testing, this is the Y test. These were the expected values, and this is the Y predict. We call it as predict. These are the actual values that my model is giving. These are the values that I should have got. I know that these are the values I had picked up from the data itself, and this is my predict. These are the predicted values. Then what I'll do is I'll compare. Say suppose of the three models, of the three values that I have, one got me the right answer and two got me wrong. So I'll say that the accuracy is 33%. 1 in 3 is the accuracy of this model, right? Now 1 in 3 is really bad, but this is because I'm just working with 3-4 values. It is like this. Suppose if this was 10 and I got this as 10, my model accuracy becomes 66% because 2 out of 3 times my Y predicted was the same as the Y testing value. So what I'm going to do is using scikit-learn, I'm first going to divide this data into 70-30, out of which I'll divide the data into 4 things: X train, Y train, X test, and Y test. And once my model is designed, I will do something which will get the predicted values of Y. How will I get the predicted values of Y? I will feed this data to my model and see what are the results. It will give me Y predict. And then I'll compare Y predict with the known values of Y, and then I'll see how accurate my model is. This is how training and testing is done using the tools in scikit-learn model. That is what we'll be doing. Guys, is this understood? This is again something which is integral to every model that you design. Any doubt with this approach? Everything will happen in 2 lines. Don't worry about the code. I'm just not worried about the code. System will do it for you. But what is happening, is that understood? Any doubts with this? X train, Y train, X test, Y test, Y predict. Integral, these terms are integral to machine learning. You study wherever, whatever, you'll come across this. Rafi, your message is incomplete. Instead of 70%, if we no, then what will happen is it will lead to a problem of overfitting. We'll be talking about overfitting in one of the sessions, positively in the next session. We will be talking about overfitting as well. See, आप समझो एक चीज रफी. See, while designing a model, if I'm using certain data, while designing the model itself, and then I'm testing the model against the same value, it will obviously show higher accuracy, na? Whenever you are testing a model, you have to test it using the values which have not been used in for the design of that model. During the design itself, if I'm using those values and then I'm testing it against the same values, obviously it will show higher accuracy, which would be misleading. And that will lead to what is called as overfitting. See, understand, I don't want a model which at testing time, sorry, which at training time appears to be too good, and when you go to testing, then it will start giving you incorrect incorrect data, or not giving you the kind of efficiency that you look for. No, no, no. See, Sai, what you can do is, see, when you are training and testing, what you can do is, you can always take 70-30, and then you will design that particular model, and then you will see. If you're not happy with the accuracy, then you go for 80-20. Generally 70-30 will do the job for you. You can go for 80-30. Once you are happy with the accuracy of the model, then you can finally, if you want, you train it on 100% values. But generally that is not done. 80-20 is the limit that you will use. You will get a model which is going to be good enough. All I want is, while training, I don't want to be using up the data which I'll use for testing. And for testing the data, I need the data where I have the known results. Nahi to how will I compare whether the value predicted by my system are actually correct or not, unless I have the results which are known to us. So 80-20 max is what you should be looking at. 70-30 is the standard, but it's up to you. You can go 75-25, you can go 73-27, and so on. That is how things will work, right? So that is what we need to do. Okay. Okay. Now, guys, just observe this. How is this going to work? Everything will happen in two lines. The beauty of machine learning in Python, the reason why Python has become so popular for machine learning is because these things now, when we used to do using other languages like MATLAB and all, now it is very tedious, but it's how simple it is in Python. Observe this. Now you'll keep seeing this line so many times. From sklearn.model selection, import train test split. Now this is the library which will do it for me. Now observe this. These are the four terms that I was talking about. It will divide the data: x train, x test, y train, y test. So my data is going to be divided in four parts. Train test split is the function. This is the one which will do it. X and y. You remember what is x and y? X is the entire data but for survived, and y is the survived column. So everything would be divided. Test size is 0.33. So I've gone with say testing data as 33%. So basically we've not gone with 70-30. We've gone with 67 and 33. It's up to you. You can go 0.3 as well. You can go 0.2 as well. 0.3 would be the ideal one, and random state is equal to 1. What this means is, whatever is the data, you use the data as it is. So that is what we do. Now again, guys, if you see from over here, I've written this particular statement and it has got absolutely nothing to do with the rest of the program, because anywhere where you're designing logistic regression, this part of the code from here till the end, whatever I write, you can just use it as it is, because whatever changes I'm required to make, I'll make it over here. So precisely next time when you do logistic regression, only data analysis and data wrangling is what you will do. Rest of the code will remain exactly the same, because I've got my required data in X and Y. You give me any other data set, I'll just change the data in Y and X. Rest of the code will still remain the same. Nothing specific to the program from here on. So I've split my data into four parts: X train, X test, Y train, Y test. Now, when we spoke about data wrangling, we said all those columns which had too many values, too many missing values, we just eliminated those columns. But what about those columns where you have few values missing? We said that they are required to be replaced with the mean values of the respective columns. How do you do that? Now that is what I'm going to do using this, right? Now this is what I'm going to do. All these comments are also there in the PDF file given to you. Observe this. Now over here, my training data, I want to replace it. Xtrain dot fill na. Now fill na what? See, what happens is, any value which is missing in the data set, it is always represented as nan, which is nan. Nan is not a number. The system will always write nan. See, if you see my original data set, you see these entries nan. Nan is precisely not a number. So what I'm going to tell the system is, wherever now you find nan, you just replace it with the respective means of their column. So what did I do? On this data X train, on this data X train, fill na. What it will do is, wherever it finds a null value, it will take the mean of that particular column and replace that empty value or missing value with the mean. In place is true, that means the change is permanent. Same thing I'll do for Y. So this would be the second part of data wrangling. The reason why we did it over here is, for this I needed to use something from scikit-learn, and that is what we've got over here. So now after this particular statement, there won't be a single missing value. All those values, all those columns where too many values were missing, we've already eliminated those columns, and all those columns where little bit of data was missing, what we've done is we've replaced those values with will replace those values with the mean. So that is what we've done. I think Rafi was asking this. Someone else should also ask the same thing. So this is where we do it. Now all set, I have everything. Now I'll create my logistic regression model. And guys, literally 2 lines is what I will need for implementing regression model. If you remember, linear regression happened in 2 lines. Logistic regression will also happen in 2 lines. Any model that I design in future will happen in 2 lines. You'll get used to the same function. Now, from scikit-learn.linear model, scikit-learn has all these models that we use, linear models, because the straight line behavior, linear regression and logistic regression, both are part of this particular module. Import logistic regression. So this is the class which is going to get the job done for me. What I'll do is I'll create an object of this class called logistic regression. Log model is equal to logistic regression. Log model is an object of class logistic regression. Guys, the Python course provided to you has a complete module on object oriented programming as well. Please go through that as well. What I found is that a lot of people, when they study Python, they don't pay enough attention to object oriented programming. It might not hurt you when you are writing some Python programs, but if you go ahead with ML, data sciences and all, you need to understand object oriented properly, because all the models that we are talking about, they are all 100% using say object oriented programming approach. So that is needed. All those who have studied Java or maybe .NET or all those languages, you will find it very easy, object oriented programming in Python. But make sure, guys, please go through that object oriented part. See, of the course that has been given to you, the 2 most important parts for you going into machine learning are object oriented programming, and the second one is data visualization. Just go through it, please. It won't take you more than maybe 3 or 4 hours to go through the entire thing, but it will help you immensely in understanding what we are doing over here. All I'm going to do is, say for linear regression, I'd created an object of class linear regression, pass the data to it, job done. Now what I'm doing is I'm creating an object of class logistic regression, pass the data to it, job done. Same thing I'll do with all the models that I design. Now observe this. From scikit-learn.linear model, import logistic regression, right? Now, what we do is log model is an object of class logistic regression. Now, whatever we have spoken about in logistic regression, all the formula and everything would be done by one function called fit. Now, this fit function you will find with all training models, with all the models that we design, you will keep getting this data. What I'll do is log model is an object of class logistic regression dot fit. I'll pass my training data to x train and xy to this fit function. So if you ask me which is that one line which is actually designing the entire model for you, it is line number 65 on my screen, where I use the fit function. What the fit function will do is whatever is the training data that you have for x, whatever is the training data that you have for y, and that data has been fed to this particular system, and it will design this model for you. I keep saying this, that my model design actually happens in 2 lines, and that is what it is. Also, if you see from line number 56, where I've mentioned logistic regression, till this point, there is absolutely nothing specific to this program. This is generic code. All I have to do is I have to come properly till line number 52, 53. Rest everything will remain exactly the same, word to word. You don't have to touch the code for logistic regression. Just get us the data in the desired format. Just get me the data in accurate form. My system will do the rest for you. And that is the whole idea behind programming using machine learning and AI. See, a lot of times people feel that machine learning or AI is very difficult. It is not difficult. It is about getting the perfect data. Instead of focusing that, they try to get into the tools. See, into the tools, you're not required to. You are using so many tools. Now, all those who've programmed in Python, we use this print function. I just write print something and it prints on screen. Have you ever gone into this print function ka code? What exactly is the code inside that print function? Or if you've studied say C earlier, can someone just tell me what is the code behind scanf, or what is the code behind printf? Or can someone just tell me in Java what is the code behind system.out.println? No, these are predefined tools which you've got to use. You just need to know how the tools are required to be used, and that is exactly what's happening. There are thousands and thousands and thousands of models in machine learning. You need to know how to use the tools. It's not required that you get into the tools, right? Okay. Now, once this is done, now what I'll do is I'll make the prediction. So how do I make the prediction? What did I tell you? I have some testing data available with me. Based on that, I'm going to create. Log model is the object. predict. Now this is the function. So guys, there are a couple of functions which you'll keep seeing all the time. First is the fit function, which will create the model. Then you have the predict function, which will create the prediction. Now observe this, guys. What is happening over here is when I'm putting this data for X test, I'm getting predictions. Precisely, predictions is what I had named here as Y test. So I will get the results. I will get the results for the testing over here. So now this Y train already has the data which is known to us, and predictions have got the new values that we have. The new values. I'm sorry. Y test already has the data that is known to us, and predictions are now the results that my model is throwing for the testing values of X. Now, depending on whatever I have got, I now need to create a matrix, or I now need to tell you how good or bad my model is. Now, this is where metrics comes in. Guys, please, whenever you design a model, you always have to give me the metric. You have to tell me what is the accuracy of the model that you have. So accordingly, I need to, accordingly, I will decide whether this model is good enough for me. If suppose what I find is that the accuracy is very less, suppose if I'm the designer, you are the client, I'm designing the model and I find that the accuracy is very less, I can tell you, see, the data that you've given me is not sufficient. The data that you've given me is not well defined. So I need more data to improve the accuracy. It purely depends on data. It doesn't reflect on the designer. If I've designed a model and if I'm saying the accuracy is bad, you cannot blame me. All I'm doing is I'm looking at the data. But unless I give you the measure, you will not know how to use that model. Suppose if you are the client, you tell me, no, I don't have any more data than this. Then what I'll say is that, okay, then what the best that I can do is that this is the model with an accuracy of 60%. Wherever you are okay with 60% accuracy, you can use the model. In other cases, this is not going to work. So that is extremely important. Metrics are basically the tools which are used for measuring the accuracy or a testing of a software. So from this, I've imported classification report. Now observe this. What am I passing to classification report? Y test. What is Y test? Y test is the results that my model has thrown up for the test values of X, and sorry. Y test is the values that are known to us, and predictions are the results that my model has thrown up for the testing values of X. It will compare both these. It will generate the report, and it will display that particular report. Similarly, if I want to get the accuracy score, I'll import accuracy score and I'll pass the two values, the known values of Y and the predicted values of Y. It will compare both these, and then it will tell us how good or bad the model is. Guys, line number 56 till line number 75, this is where entire logistic regression is happening, and not a single line which is specific to this particular program. So what I'll do is, if you ask me to design logistic regression model, I'll not touch this part of the code at all. I'll just copy paste it just like what I did now, and all I'll do is whatever the data that you give me, I'll pick up the data, I'll analyze that data, I'll wrangle that particular data, I'll get the data in X and Y on line number 52 and 53, and then get the job done.